the basics of synthesis, namely subtractive synthesis, which is what you need to know for the NCFE course for music technology. So, to kick us off, I'm going to open up a new software instrument track. I'm going to select Retrosynth. That's going to be my first one I'm going to use today, which I can choose from the drop-down list there. Alternatively, what you can do is add a blank MIDI track, like so, and then in your library, select, sorry, not the library, in the inspector, select instrument, and from this list you can find Retrosynth just there. Great, okay. I'll go back to this one just to keep my project nice and tidy. So I'll open up Retrosynth from my inspector, and it looks like this. When it comes to using any synthesizer plugin, be it within Logic or any others, always make sure to wipe it clean. And what I mean by that is there's a default sound, a sound that's already loaded in, and you can clear that by going to the top menu here and selecting Initialize Setting. That'll just wipe away any patches, any connections, anything like that that's going to affect the music that you're making or the sound you're crafting. So I'll select Initialize Setting, and we should now be able to hear a synthy sound. Perfect. So with any synthesizer, you always start off with oscillators. These things over here, they generate a sound using waveforms. Now the waveforms all look different and have different sounds, and if I play for some of them for you very briefly, this one is a sawtooth wave, quite a buzzy sound. This one is a square wave, a bit more kind of tubular. This one is a pulse wave, a bit more kind of nasally sounding. Finally, you have a noise wave here, which, as you may have guessed, sounds just like noise. There are other waves, but just to explain why there are waveforms and what I'm talking about the waveforms very briefly, I'm going to use an example that I've got prepared behind here. I've got two audio regions here. One is a guitar recording, and one is a recording of a synthesizer. Here's the guitar. And here is the synthesizer. Now if I zoom in on these regions here, make a little bit more room so we can see. If I zoom in on my guitar, we'll see the waveform is quite complex. And don't forget, the waveform is just a visual representation of the sound we're hearing. We can see the sound goes to positive and negative, and I won't go too much into detail about exactly what all that means, but simply we can tell that an audio recording of a voice, a guitar, is quite complex. Whereas a synth wave, not so much. Here I have a square wave, and as we can see, the waveform is just squares. If we recorded a sine wave, a triangle wave, or any other wave, the shape would also resemble that shape. The idea here is we have a repeating shape, and that generates a tone. It generates a continuous sound that we can use as a note. Good. I'm going to return now to Retrosynth. Okay, so I can choose between oscillator 1 and oscillator 2. I can generate two different waveforms at the same time and to create a more complex sound, and go between them with this little slider here. Most synthesizers that have multiple oscillators will have some way to blend oscillator 1 and 2, or 1, 2, and 3, depending on how many oscillators they have. You also then have some controls here for the tuning, where you can adjust things in individual semitones if you want to, or in cents, which are a percentage of a semitone, plus 50% or minus 50%. Great, so what I'm going to do, I'm going to start off with just one wave using oscillator 1, and I'm going to choose a square wave, which sounds like this. Perfect. Now the next stage with subtractive synthesis is running your oscillators into a filter. Now a filter, just like a coffee filter or any other kind of filter, it removes sounds, or more particularly, frequencies. What we're seeing on this kind of small graph we've got here is the range of human hearing, where we have the lowest sounds down here at about 20 Hz, and the very highest sounds up here at about 20,000 Hz. All we're doing with this filter is removing some of those frequencies. At the moment, if I adjust this, we don't hear anything different. But if I turn it on, we should hear some difference. Good, so there's two things to consider with a filter, or two parameters: cutoff and resonance. Cutoff is simply the point at which the frequencies are rolled off. So in this case, I've got a low pass filter. It's only letting through the lower sounds. As I adjust the cutoff here, which is this kind of dot on the x-axis as I moved it left and right, it changes how many of the frequencies, or what amount of the frequencies, are being rounded off, are being gotten rid of. If I take it to about 60%, it's pretty high, but if I go lower, it's very, very bassy, and we can't hear the sound much at all. We can change, though, whether this cutoff is removing the high frequencies, the low frequencies, or other frequencies, depending on the type of filter. If I select a high pass, for example, we'll then have the opposite. Finally, we have a band pass, which is kind of like a middle version, we can adjust the mid frequencies, a high and low pass filter combined. For the sake of this, I'm going to stick with a low pass filter. The second parameter we need to know about is resonance, and simply resonance is at the point of cutoff where those frequencies are rounded off, how much that particular point in the frequency spectrum is boosted. So if I have a high resonance like this, it has a slightly different kind of timbre. This will be more evident as I move it up and down, or move the cutoff up and down. If I compare it with a very low resonance, it sounds quite plain, but a high resonance introduces quite a different character to the sound. So with a filter, there's two parameters: cutoff, the point at which the sounds are rounded off and cut off, and resonance, the point at the cutoff, how much the sound is boosted, or how much that particular frequency is boosted. Don't forget there are other types of filters here where we can remove off just the lows, just the highs, or both. That's the first part of using a subtractive synthesizer: oscillators and filter. These generate the sound, these filter the sound. We then have these parts down here, our modulators. Our modulators commonly are an LFO, or low frequency oscillator, and envelopes. I'll start off with the LFO. Now an LFO is simply, like I say, a low frequency oscillator. Don't forget these guys are called oscillators too, but this one isn't one we hear. It's one we use to apply to something else to modulate the sound, to change that sound and give it a different character. First of all, I can choose the waveform, just like I can with these guys, but this time, like I say, it's not one we're hearing it applied to something. What I'm going to do is I'm going to apply this LFO to my filter. So, let's bring the resonance down, let's bring the cutoff a bit higher. And what I'm thinking is I want this cutoff to move like that, to give it some movement and make the sound a bit more exciting. I can use an LFO to do that. So an LFO is just a repeating shape, just like a waveform that we saw earlier at the oscillators. It's a repeating shape that we can apply to something. So if I apply this shape to my filter, it'll jump from high to low, to high, to low, to high, and again, simply following that shape as it's been told to. If I choose a different shape, so for example a triangle one like this one, they'll be much more smooth in its movement and have a different character to the sound. Now to apply my LFO to my filter, it's very synth to synth how you go about doing this. On this particular synth, you have a dedicated dial for attaching these parts down here to things in the top half. So let's say I want to apply my LFO, and I'll put it onto let's go back to the square wave. I'll just simply take this dial up, I'll bring my cutoff a bit higher so you can hear it. And already we can hear the sound, bum 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 bum. It's got a rhythmic high and then low and then high and then low. It's quite fast, so I'll slow it down using the rate. High, low, high, low, high, low. Just like that. Let's try a different shape. Let's try a ramp up or a reverse sawtooth. Again, we can hear that shape ramping up and that cutoff moving from low to high, and then suddenly resetting low again and moving from low to high. Let's try one last one. Let's try a regular sawtooth, and let's make it quite fast this time. Rather than work in hertz, we can also sync it to our global BPM. We can synchronize it with the tempo for our project. This will keep it in time with our drums and other parts going on. A 16th or a semiquaver will be that fast, whereas if I change it to, say, a quarter or a crotchet, or combine multiple notes, I get some interesting results. So an LFO is simply a repeating shape that we could apply to something else. Here we've done it to the filter, but we could apply it to the pitch, we could apply it to the amplitude, or multiple other things. An envelope, similarly, is a modulator. It's not something we hear, it's something we apply to something else. However, it's different to an LFO because it's not a repeating shape. It simply does its job once and then it's finished. This could be every time you trigger a note, or it could be the start of a phrase, depending on what legato settings you have for your MIDI, but simply it triggers once and is done. It doesn't repeat like an oscillator does, or an LFO does. I'm going to start with this one, the amplitude envelope. So, I'm going to remove my LFO that I applied just to make it a bit easier to hear what's going on, and turn off my filter for a moment. What I then have is simply the clean sound I've made here, which is just a square wave, without anything added. On my amplitude envelope here, I can adjust how long that sound goes on for, how long it takes to fade in, and more things like that. There are 4 parts to it. A, attack, D, decay, S, sustain, and R, release. First of all, I'm going to go ahead and take my attack and release all the way down to 0. Now, an easy way to think about attack and release is simply fade in and fade out. With a very short attack and a very short release, this will mean every time I press and hold a note and release it, it'll stop dead, like this. There's no fade in, no fade out, it simply enters and exits. Just like that. If I take my release up, then the point I release the key, I take my finger off the notes, it'll then fade out according to this time frame, 340 milliseconds. So let's try that. I'll take my finger off the key, and I'm pressing them very, very briefly there. And we hear it's got a little bit of release, a little bit of a fade out. We can do the same thing with our attack. If I make that a little bit higher, we should have a little bit of a fade in. Let's make it about 190 milliseconds. So now we have a sound that fades in slightly and fades out slightly. Let's try a long attack, maybe about 3 seconds, and a release a bit longer as well, for more of a pad type sound. Good. So that's attack and release. There are then 2 other ones to worry about, decay and sustain. An easy place to start would be sustain. And what I'm going to do, again, I'll keep my attack and my release low. So we're back to this short, sharp and dead sound. If I take my sustain down, this one here, all we're left with then is attack and decay. We'll see this line is flattened. This means when I pluck a note, it's so short you can barely even hear it. Let's try taking the decay up. About 1 second. Now we can see there's no attack, there's no fade in, but the shape of the sound decays here. It goes down to the point of sustain, which is 0. Let's make it a bit shorter, about half as long. If I bring my sustain up to full, it doesn't decay at all, because it's simply up, holds, and then releases flat. However, if I take my sustain about halfway, and might decay a bit longer, we get a more complex sound. Maybe I'll add a bit of attack as well and a bit of release. So a shape like this, where we have a very, very quick fade in, maybe even quicker than that, a little bit where the volume dips down, then it does sustain, it does hold, and finally releases when I release the key. This is something like, for example, a guitar string. If I were to pluck a guitar string, I'd hear the initial twang, and then it would ring out and we still hear that note, but you give that little kind of sharper, slightly louder sound right at the start. I'll make my decay a bit shorter so you can hear it a bit more clearly. How long we make that decay is simply how long it takes to reach from that initial point where it fades in to the point where it sustains. That is what decay is. You may think, what's the point in having decay? Why not have to just fade in, hold, and fade out? It's a valid point, but with decay you add one more parameter, which gives you more flexibility and more options to create more complex sounds. Good. Now we can apply this theory where we have fade in, hold, and fade out to other things, not just amplitude, not just our volume. We can also apply it to our filter, this thing here. So what I'll do, I'm going to reset my amplitude envelope so it has a full sustain, no attack, and a little bit of release, just like that. Great, okay. I'm now going to head to my filter envelope, and with this one I'm going to make a bit of a different shape. So let's have a short attack and make it fade out so we get a kind of plucky sound. Now so far, nothing will sound any different, because just like before, we need to do some routing, we need to attach it. By default, we didn't have to do anything to our amplitude envelope to make it react, but with our filter envelope, it's slightly different. We have to use the dials here to say, I want this attached to this. So let me turn on my filter. I'm going to make it a bit more gentle, like so. Good stuff. Now what I want is my filter to, every time I press a key, start high and jump to low. I can do that using this shape, where I've got starting high and jumping to low, but all I need to do now is attach this to this. I can do that with this dial here where it says ENV, ENV for envelope. It starts at about 12 o'clock and I can take it to the right to get a positive value or to the left to get a negative value. If I take it to the right, it'll impose this shape. So now we should hear a kind of dow kind of quality to it. The filter will start high and jump low. If I make the resonance a bit more extreme, or make my decay a bit shorter, I'll get a different sound. I'm going to make the release a bit shorter on my amplitude envelope for less of a fade out. There we go. Now if I bring it to the left, I'll get the opposite result. It'll start low and move high. So I can use this to create an inverted envelope. Great. That's the premise of subtractive synthesis. We start off with oscillators, which are generating waveforms, and they run into a filter. That filter can be set static, or we can apply things like LFOs or envelopes to it. There are many other forms of synthesis, such as FM, a wavetable, and so on, but we're not going to worry about those too much now, because the main reason being, not only are they very complex, but you don't need to know them for the NCFE course.